Top one. Okay, can everyone see my screen?
Yep.
Yep, awesome.
Yeah.
Okay, good. Okay, so this is the GitHub repository that we've been keeping for these discussion sessions, and so they're open and available online, and we were just putting these together as we went along through the deep learning book. And I want to continue adding to it and building it out for people that are learning and just getting into this type of work. And so basically, the way it's structured is pretty straightforward. We just have a folder for each specific chapter that's covered. And then if you click on that specific chapter, you get access to the previous video. We also link in the chapters that are discussed from the deep learning book. Obviously, it is available online for free, so you don't have to order a copy if you don't want to. They have made it available for everyone. And then here's a copy to the presentation slides that I set up last time. And we can, actually, I'll put these in a separate tab. So if you want to follow along with those presentation slides, you're welcome to do so. And then this is a link to the online video for the first discussion we ever held for the deep learning book. If you haven't had an opportunity to watch that yet, obviously this session is going to be hosted a little differently, but it is still valuable. Went through a lot of the basic material that was covered in the book. And so I would like us just to go through each one of these slides again, but again, really just talk about the different topics, make it more of a discussion and less of a presentation. And then if at any point anyone has questions or they want to point out something that was discussed in the book itself, please just unmute yourself and we can kind of go from there. So let's just start with the intro. The general concepts of artificial intelligence, machine learning, and deep learning. Is there anyone in the room that hasn't had an opportunity to read the book and it doesn't really understand the difference between these three topics? Okay, it seems like everyone understands. So I'm going to pick someone at random and ask you to define it in your own words. Let's see, we have a new person that hopped on that hasn't introduced themselves yet. So I'm going to make this an opportunity for them to introduce themselves. It looks like their name is spelled L-O-A-I. So hi, we all went ahead and introduced ourselves already. If you wouldn't mind just saying your name, your background experience in artificial intelligence, and what you hope to get out of this session. And then if you wouldn't mind starting us off and just saying in your own words, how do you define artificial intelligence, machine learning, and deep learning?
My name is Luay Najjar. I am an embedded FPGA SoC IoT professional.
Mm-hmm.
I interested a lot in artificial intelligence, machine learning, and deep learning. Artificial intelligence is started a long time ago, and it was supposed to basically replace the human learning, human intelligence, and it did not really work out.
Mm-hmm.
Ended up being specialized expert systems only.
Mm-hmm.
In like lawyer, electronics, or so machine learning is the newest thing that where the program actually learns from itself from big data.
Yeah.
And it has a problems and really advantages. The problem is because you end up not knowing how it's unpredictable. It's how the machine will learn from the data.
Definitely.
And this is in automatic driving machines. That's kind of dangerous, and that's why I think Intel came up with a math formula to basically, in case of a problem, it prevents the end result of the machine learning from doing something wrong.
Okay.
And deep learning, I'm just learning about that. I don't know what you guys say deep learning. Thanks.
Okay. Yeah, definitely. Thank you. Thank you for your input. And for new people that may not be familiar with what expert systems are, if you haven't done work in machine learning or software engineering before, expert systems are logic-based systems. So like for the example that he gave, tax accountants have been using expert systems, and law has been using expert systems for quite some time. TurboTax is a good example of that. You just take rules that have been developed for applications to a specific area, and then you just put those in a software product so that depending on what questions it asks and the answer that you give, it'll give you a certain type of result based on those questions and answers. So obviously that's what a lot of people thought of as machine learning or artificial intelligence some time ago, but things have come along quite a bit. Does anyone else want to add to that, basically their understanding of artificial intelligence, machine learning, or deep learning?
Yeah, my understanding, I don't have my understanding of deep learning, at least, is that deep learning is basically a form of neural network where you have more deeply layered neural networks, which we use to have the machine learn its own features, discover features as it goes through this concept of going from one layer of the neural network to the other, and by virtue of that, be able to figure out the structure within the data, the meaning, so to speak, within the data that it is training on, and by virtue of it, is able to understand what it is doing. Because when you train it with as a supervised learning model, which is what I know of, you kind of get to know, and the machine kind of gets to know, it discovers features, and by virtue of it, it's able to pick a model that better describes the data that it is learning on. Well, artificial intelligence, I assume, is a more generic field which involves machine learning and deep learning and other forms of domain analytics involved in there, to be able to have a more intelligent system. But I don't really know. I'm really not really comfortable giving a single explanation for what artificial intelligence is. But my assumption is that it is basically deep learning, machine learning, and domain analytics combined to give a more aware system, which not just which can both learn and transfer learn. I don't know.
Yeah, definitely. Thank you for adding that. So I think one of the main differences that no one has brought up yet is the difference between supervised and unsupervised learning. Does everyone understand the difference between the two?
Yes, I do.
Yeah. Yeah.
Yeah. Okay, great. So why don't we have someone volunteer to explain the difference between supervised and unsupervised learning in your own words?
Yeah, I can do that. So in the case of a supervised learning model, we provide the system with features and the labeled and the label, which would kind of lets the machine know, what is the what it is that it is trying to learn, in the sense that the system can know in advance what it is going to predict. Meaning it knows that this, for example, given supervised learning to figure out learn images, learn from images. If you give what the image is and the data set, the image data for the algorithm, and it trains on, then that's a supervised learning where you actually provide label the data set to the model for it to learn. Whereas if you provide an unlabeled data set where the data is just provided and the machine has to figure out what's in the data, then it is an unsupervised learning model where the example would be um, learning from the case of I would say learning from text, the field of what's that? I keep forgetting the the natural language processing, things like that, where the machine kind of learns from the text what it is that the text is trying to say, and things like that.
Yeah, definitely. Thank you. So that was, yeah, go ahead.
Can I add something?
Yes, please.
I mean, so like I said before, I'm a newbie, and I'm attending actually like Andrew Ng lecture of the Stanford for this, to get familiar with this AI and machine learning. So for the supervised and unsupervised learning, he gave actually good example to learn. So so for the supervised learning, you actually provide it provide input, but there is a corresponding I would say a target or goal to achieve with the help of training. For example, if you take the classification algorithm, like you want to you have a set of data and you want to like so like you are buying a house, and like you have a particular set of data of the different areas and from the past few years, then you can actually based upon the data you can classify, okay, for example, your budget is this much, but based on my data, I'm getting this much amount. So I mean, you can actually classify with the help of classification algorithm, you can come up with that with the goal of buying the house or something. So it is, in a nutshell, it is actually uh, with the help of it, you train your machine to get the desired result. In case of unsupervised learning, there is actually, it works. I mean, machine comes up with its own structure or the relationship based upon the data. For like if you take the example of the K-means cluster, K-means algorithm, and if you wanna, so I'm giving the example of the cancer prediction, anomaly detection. You have the tumor values, and you have the size of the tumor and the different ranges of values. So based upon the like your tumor size and the previous the tumor sizes value you have, like you can form the cluster and you can determine, okay, like my this tumor size doesn't fall in the various groups of various groups of clusters, sort of like that. So I hope you guys understood what I said.
Yes, you gave a lot of real-world examples of how deep learning is being used now and neural networks are being used. So thank you for sharing that. And yeah, I think the core concepts to the difference between supervised and unsupervised learning. Supervised learning is a traditional form of machine learning where normally the data scientist or the researcher does offer specific features for the machine learning algorithm to look for with help in identifying what an object is, right? Or to derive meaning or context from a word or from a corpus of text, for example. Whereas in unsupervised learning, you are not necessarily identifying features ahead of time, and you're allowing the neural network to do that itself. And so in this way, it takes less of the responsibility or takes less time from the individual training the neural network to put in the time that it would need to take to get something done, right? So deep learning in that way utilizes larger data sets to extract those features and then really derive context or meaning from either that corpus of text or an image itself by looking for patterns that it's seen previously based on your training data. Great. So I think in that way, then everyone has a good general understanding of what the difference between machine learning and deep learning is. And obviously artificial intelligence is just an umbrella term that, just covers all of these areas. But what I'm curious from you guys, do you guys still consider robotics to be a form of artificial intelligence?
I don't know. I think not.
You think no? What if the robotic system incorporates neural networks? Then would you think of it as artificial intelligence?
Yeah, maybe, yes. I would say, yeah.
Yeah? Yeah, because robotics has been around a really long time. And I think when most people think of the word AI, their mind goes to something like the Terminator, right? Or something like when they talk about jobs being replaced by artificial intelligence, oftentimes what they're referring to is like automatic manufacturing systems, which is robotics. So I'm curious if you guys as engineers or data scientists or machine learning enthusiasts, how you feel that robotics fits into this idea of AI today.
Yeah, sorry, Laura, I didn't quite get the question.
Yeah, just I wanted your general consensus. Like, how do you feel that robotics fits into the umbrella term of artificial intelligence today? Do you think it's something that the media just puts out there, and that maybe the layperson has come to associate this idea of AI as being this robotic system or an android, for example? Or do you not think of that when you think of artificial intelligence?
Yeah, I mean, I don't generally associate robotics as some as primarily the vehicle for artificial intelligence, but I do see that um, the the artificial intelligence as a whole, in terms of systems that are both software and hardware that are around. Um, uh, I tend to think that the notion that there will be systems which are autonomous, which make decisions, or which know things, kind of has this has the media talking about it. I would say it's not just robotics. There are other forms of things around us which can have which can be in um, um, uh, taken, or the wrong word to use, which can be revolutionized by uh, infusing intelligence into it, which is what I would say is something which causes the media to talk about it.
Yeah, definitely.
I just want to add a few things here.
Sure.
Robotics is more like how it is going to sense things or sensors, and there are lots of other electronics terms are associated with it, right? There is some intersection point between robotics and AI, So there might be some intelligent unit robotics is being added. Let's suppose if we think about like if it start thinking really like human, or something like it is doing not only from the sensors and all those like activities around it, if it is just reacting on the basis of that, or how it is going to analyze that data, and on the basis of that analysis how it is going to perform. If these two things are combined, then I would say robotics will come, and it can be under the whole AI umbrella. But for now it is still in that like way. Down the line it might completely come to areas like it can embed the deep learning or other like algorithms, so that it can analyze whatever data it has, on the basis of it can make the decision. And if that becomes possible, then I think it will be. Otherwise for now, let's suppose some normal kind of tasks it is doing, like production, manufacturing industry and all those areas, there are fixed set of rules defined, and it is just following that instruction only. In that case, I would say that is not the true machine learning or artificial intelligence.
Great.
So I have, one small point to be added with the decision of Manoj.
Sure.
So I was involved in the robotic competition when I was, a graduate student. So there I used to build up robots with the sensor follower, with the basic programming. And now you can see with the like Sophia and like inventions in the robot. So I would say robotics is very old, and but the medium of intelligence or innovation in the robotics is changing. Like 50 years back or like 20 years back, it was something different, and now it is with the help of AI, it is becoming like advanced. So like robotics is just a way of building robots, but AI is to give a programming intelligence to the robotics system. So I would say they are like different, and AI is just helping robotics to make it like more innovative and advanced. That's the thing.
Yeah, definitely. Thank you for sharing that. Okay, let's move forward on to the next slide. So they try to set up the chapter and our idea of AI and deep learning with obviously the basics, right? So data representation and feature extraction is necessary in order to do AI. And one of the ways I've used data described in reference to artificial intelligence, and I really like this analogy, was that data is the fuel, right, to the artificial intelligence engine that then does all of these math calculations for you and really allows the system to learn on its own. So when looking at this graph, which comes directly from chapter 1 of the book, they go into depth about the difference between a Cartesian coordinate and polar coordinates. Does everyone understand this image, or does anyone kind of need an explanation of what's happening in these two different coordinate planes?
Yeah, I would need that. Thank you.
Yeah, of course. Yeah. So everyone's pretty familiar with an X and Y coordinate system, right? That's something, if you've taken any type of algebra class, that's something that has been taught for a really long time. And so the Cartesian coordinate plane, which you see on the left-hand side, is just that. It's a representation of the X coordinate system and the Y coordinate system. And so it looks a little different than you would normally see it plotted. Let me see if I can do, I know I can annotate here. Drawing. I just have a freehand. Let's see if this, cool, okay. I'm glad we switched to this new system. So yeah, if you're used to just a general like X and Y coordinate system, right, where this is an X and this is a Y, so that's all that this Cartesian coordinate plane here is, right, showing you. So everything along the X-axis, you can have like a ton of points here, will also have a coordinate along the y-axis. And they could be anywhere in the system. But this image is taking kind of a top-down view. So instead of looking at it as a two-dimensional graph, like here on the left-hand side, you're looking at it kind of from overhead, right? Does that make better sense now to you?
Yeah, thank you.
Yeah, of course. And then the polar coordinates here, when doing feature extraction specifically, sometimes they refer to polar coordinates as just taking all the data that's been represented in a standard Cartesian coordinate system, and oftentimes they do dimensionality reduction when the neural network is trying to really pick out different features and cluster them into these different areas. And this is something that's been done in machine learning for some time, right? They try to separate out all of the data into different planes, right, into different poles, so that it allows you to get a better idea of what each piece of data actually represents. So in this polar coordinate system here, if you just like draw a line down the middle, then you know that any data that's on the left-hand side is associated or clustered or representative of one specific feature, and everything on the right-hand side is representative of another potential feature. Does that make sense to everyone?
Yeah, thanks.
Yeah.
So we're seeing this, it's basically the same Cartesian coordinate representation compressed into a polar representation. Is that right, Laura?
That's my understanding of it. And if anyone else has a different understanding, I welcome you to speak up and join in the conversation. Yeah.
Okay, yeah, even I don't know. Okay, it seems that way to me as well. So what you're saying is that the coordinates have been compressed using dimensionality reduction to kind of get to a more to find a fit this line. That's what you mean, right?
That's correct. Yes.
Okay. Thank you.
Yeah, of course. Okay, so let's move on to the next slide. Let me get out of my drawing here. So they talk a lot about, oops, those are still there. Let me erase them. They talk a lot about the deep learning model, right? Like what exactly deep learning is, and they represent it here through this image, which we've also taken from the book. And here they're providing an image of this person. Obviously, we can all see that that's a human. But if you want a computer to actually recognize this person, then it has to go through this deep learning model, which is a neural network. And they just want to describe how the neural network works. And so if you're new to deep learning and neural networks, the basics is that they break up the image into pixels, right? They normally do what's called a spotlight effect, especially for convolutional neural networks, where they convolve over each specific area of the image, and then they move along the image little by little. And when they do that, they extract specific features that are represented in that image, and they try to basically assign weights to each feature. And then from there, so it goes from this visible layer, which is the input pixels, and then it goes through each hidden layer, which are just nodes within the neural network system. And so as you see, this first hidden layer here defines just the edges that are taking place within this, within these pixels. So it does that dimensionality reduction, and you start to really get those specific edges defined. And then from there, it really tries to extract more specific features. So you go through a second hidden layer, you get corners and contours, and then a third hidden layer, and then you really start to tease out like what are the different object parts that make up everything that's happening within this image. And if the learning model has seen a person before, it should be able to properly identify that what is in this image is a person and not an animal or a car. Does anyone want to add to that explanation based on their understanding?
No, I think the multi-class model is what we see here.
So, Laura, I have one quick question here.
Yeah.
In each hidden layer, it's like, will it incorporate any other like learning algorithm, or how it is going to work?
Yeah, so there are other algorithms that are incorporated depending on the type of neural network, right? Some of them incorporate something called a ReLU. Oftentimes they'll incorporate backpropagation, especially for deep learning neural networks. And then there's different types of deep learning neural networks, right? There's the convolutional neural networks. There's the recurrent neural networks. You know, so it really just depends on what goal you're trying to achieve. And there are different ones that are used, whether you're doing, if you're working with images and you're trying to do computer vision, or if you're doing natural language processing, there's different specific kinds of algorithms that are being applied. So this is just an overall high-level model of the deep learning system.
Oh, I see. So here we are just showing the architecture. So like,
yes.
It is kind of bones or something like that. Inside, what you are going to feel, it depends on what kind of environment you are dealing with. Is that correct?
Yes, that's correct. Yeah.
Okay. Thank you.
Yeah, of course. Any other comments or questions on this slide? No? Okay, cool. Let's move on. So on the next slide, so they go a little bit into computational graphs. Again, it's just a high-level representation of the calculations that are taking place that you'll often see covered in different research papers. So they want to make sure you have an understanding of what these graphs mean and how they represent you know, different algorithms that are being used in deep learning calculations. So this is something that's still not incredibly intuitive to me when looking at this item, but just a general overview, a computational graph is a directed graph where the nodes correspond to the operations or variables. The variables can feed their value into operations, and operations can feed their output into other operations. This way, every node in the graph defines a function of variables. So if we look at this, we have the element set on the left-hand side, and so we know that each of these is a specific node, right? And these different calculations that are taking place, either addition or multiplication, are all taking place throughout each step within this computation, and eventually they'll lead to our output, which is this theta here. And each of these starting points are going to be your inputs. And those inputs can be general inputs from the start, you know, of your model, or they can be the weights between each of the hidden layers. Does that make sense to everyone?
Yeah.
Yeah? And does anyone have a better way to explain computational graphs to a new person who's looking at this for the first time and might not understand what it means? No, well, that's okay. None of us are experts here, and so we're all just kind of learning with each other. If at any point someone does, please do share it with the group. At the end of these slides, I have resources, additional resources that are available. And so one of them that I found was this cool blog that goes a little bit more in depth into computational graphs. So if that's something you're interested in looking into that you think might help you better understand these deep learning models when you're doing research, you know, please check that out and see if it helps you in your understanding of this material. From there, the authors go more in depth into the differences between deep learning and machine learning and artificial intelligence. And you get this better overview of AI being an umbrella term, right? And where each different type of algorithm within artificial intelligence fits into every step to get you down to deep learning. Let's see, what they don't really cover in here is topics like deep reinforcement learning. They're obviously a part of deep learning, but I just want to bring that up because this is not representative of all the areas of AI, right? There's many other areas that also fit in here, and they just give some basic examples. So knowledge bases in general, systems that hold knowledge or systems that can think either supervised or unsupervised. The idea of machine learning with an example like logistic regression. I think someone brought that up earlier as an example with the housing market. Linear regression and logistic regression is often used in order to figure out the value of homes in the housing market. And then you have representation learning, which brought on the idea of these shallow autoencoders or perceptrons, which we'll get into a little bit more. And then, of course, that led to deep learning. And these models have really taken off in the past 2 years. Does anyone want to add anything to this slide? Any questions or comments? No? Okay, we can move along. And the next image, here they go a little bit in depth between the differences between each type of system. So obviously we have the role-based systems where you have an input, you have a hand-designed program, and an output. So that's kind of like those expert systems that we talked about earlier, things like TurboTax, which have been around for a really long time. And of course, I think someone else brought up, the robotics has been around a really long time, right? But we don't really consider like basic robotics to be artificial intelligence anymore. But the idea of AI has been around since the 1950s, right? So this isn't new. This isn't a new idea or new concepts at all. But it's just having a revival right now. And then from there, obviously, the classic machine learning models have those hand-designed features. From there, they map between features and they find relationships between the features that an individual provides for the system. And then they create an output based on that. And then this unsupervised representation learning, which has really led to deep learning, you don't normally provide the features, or if you do, you provide examples through your training data of simple features. And then from there, the system could map map the relationships between those features, or the more layers that you add to the deep learning system, it could really allow for those abstract representations of these features. And then they map from those features to really derive what your output is, hopefully without overfitting the system. Does anyone want to add to this point or slide before we move on? And at some point, I might just unmute people randomly and get you to talk.
Yeah, one thing that I'm still not learning. I've still not learned is the approach of that with deep learning. We still give a label. We still give a labeled data set, right? But the features in the data set are being learned by the machine or learned by the algorithm as it goes through these layers. Correct?
Yeah, that's correct. So for example, if you're doing computer vision, what you want to do, the data set that you're feeding into the system, I don't know if you guys have run like a basic example using the, what's that one put out by Google? The TensorFlow for Poets. Have you guys done that project yet? Basically what you're doing is you're just taking a data set of images which is, it's labeled very generally. Each set of images, right, of different flowers, for example, all the roses are contained within one directory, and all of the like irises are contained in another directory. And so when you feed it into the model, right, it has a general label through the directory that it's held in, right? So each individual photo isn't necessarily labeled as the type of flower that it is, but because it's sectioned off or clustered off into this specific directory labeled flowers, right, or roses, right, then from that, the machine or the algorithm learns to associate those pictures with that label. So yes, you are still potentially providing a label to that system, but that's a very basic deep learning system, right? As they get more advanced, I think there have been ones at this point that do not even offer labels to the system, and some of them, when these deep learning algorithms are connected through a network, right, on different servers, they actually can learn from each other, learn from the experience of other deep learning systems, which I think is super cool. So yeah, so thanks.
I had a question about the data. This is Victor. Because what I've seen is sometimes these systems, they do have to, one of the problems that some organizations will have is that they'll have quite a bit of data and it'll be scattered in different types. And it seems like you'd have to normalize it somehow so that that the system can take that input and give you some type of output, or else it's going to be garbage in, garbage out, right?
Right. That's correct. Yes. Yeah. That's a good point. Is that there's still a lot of work in deep learning and artificial intelligence that really is just data processing, right? You have a lot of data that sometimes considered dirty data because it's not necessarily ordered correctly. It's not labeled. If it's names or numbers, they could be potentially in different formats, right? Or it could have missing values. And so a huge part of the process of doing artificial intelligence engineering or data science is still that data processing aspect. And I think there are a few companies at this point that are trying to apply machine learning and deep learning to automate that process as well. But that is something that does have to be considered as you're working with this type of technology.
Yeah, that's right. In fact, I kind of hear of a few of them, like Alteryx, Data Robo. Those guys kind of have automated ways to cleanse data and even to train data. So
yeah. And I think companies will develop their own processes and models for doing data cleaning and data preparation based on the type of data that they're working with, right? And again, like what they're trying to achieve, what their expected output is. It's very specific to the data that you're working with and what your goal is in doing this work. So thank you guys for bringing that up. Are there any other comments or questions on this part?
No, at this point, yeah. No.
Is there a way to the output to feed it back into the system itself in deep learning?
So I think that's basically what's happening between the hidden layers, right? Because every time you go through a layer, each layer has an output. And depending on the type of algorithm that you use, sometimes that output could be kind of a representation of all the information that was given to it, and it could come from many sources or it could come from one source, right? And so that's part of how deep learning works. And so and then also depending on the specific model, like if you do backpropagation, it'll go back through and look at all the outputs from those specific hidden layers and then normalize all of those weights. And then that becomes what your individual output is for that one process, right? And so most of the times when you run a neural network, you don't usually do it with, just kind of standalone. Oftentimes you'll run several algorithms together until you actually get the thing that you're looking for, right? The specific feature or the prediction that you're trying to achieve. So so yeah, so it can be fed into another neural network for continued learning to improve efficiency. Does that answer your question?
Yes, thank you.
Yeah. Any other questions or comments on this part?
I have one curious question. I was going through one blog and I saw there one concept like human in loop concept. So where it exactly falls under, it falls under the deep learning umbrella itself, or how it works?
A human in the loop.
Yep.
I've never heard of that concept personally. Would you mind explaining what they said about it, or if anyone else has heard of it before?
Yeah, I think I've heard of that term before. My understanding is that the human in the loop learning is basically where we kind of help provide the meaning to the data for it to kind of learn more. I think it's kind of um, um, yeah, I think it basically where the human comes in to provide some meaning to the data that it sees, or some for example, it's an image, this image with a cat and this, this other animal or something like that, to kind of provide some more context to the data so that it can train furthermore. That's my understanding of this.
Interesting. Here I see, I found an image online. I'm going to put this on my screen and we can talk about it a little bit more. And this is just from Google Images. So this human in the loop. So if a machine learning algorithm does not have a high confidence output, for example, you could allow for human annotation, right? Or maybe further definition by humans prior to really giving your output. So where I think this is valuable, or maybe would come into play, if you've heard about, obviously most people have heard about these AI systems now that have been beating really well-known chess players or Go players, right? Those systems still have not been able to beat a human that's playing alongside one of these systems. So in that way, having a human go back through and check or add their experience level to whatever task you're trying to achieve can potentially add for additional confidence or additional maybe feature extraction or prediction than you would get with the machine learning or deep learning algorithm alone. So just looking at it, I think that sounds, that's probably what they're referring to with human in the loop. But if anyone else has thoughts, please add them.
So here it's that discussion at that time, presenter said it is kind of, we have two kind of machine learning system, right? One is supervised and another is unsupervised learning. So
Right.
this is kind of semi-supervised learning system.
Uh-huh.
So if there was one application, I forgot the application name, but it was more about looking into the email and scheduling the meeting on the basis of what's conversation going on that email, right?
Right.
So, it will schedule one meeting and it will send to both parties, but in some scenario it might miss some keywords or some learning mismatch is happening. In that case, human has to involve to correct that information or something. For that kind of scenario, is one scenario was given, and other is let's suppose this algorithm is really doing bad, performance is really bad. Let's suppose algorithm is just giving 30%, this image itself, out of 100% confidence it is just giving you 30 or 40% confidence, but you want to see why exactly it is happening and how it is going on. And on the basis of that result, you are going to change the algorithm, or you are going to add extra labels or extra different kind of data, so that that particular algorithm is going to learn something. That's pretty much I can remember right now.
Yeah, definitely.
Yeah, you know, I had a question, because that's something that I've always been interested in, kind of what types of checks and balances are put in place. Like he was just saying, you know, if you're not confident, or if maybe it's an algorithm that's not performing to where it should, how do those get caught so they don't get propagated? Does anyone know? That's just a general question, I guess.
Yeah, so I don't know if this applies directly to human in the loop, but definitely that's something that has been brought up a lot with ethics in artificial intelligence, and making sure that we're not creating bias systems. And for people that are brand new, bias has two different meanings in artificial intelligence. There's bias that we understand, obviously, in a societal structure, right? When a group of people can be biased, or an individual can be biased against a group of people. But then there's also biases within the machine learning algorithm, which is not the same, which has to do with the calculations that are occurring while the neural network is processing, and going through its data. So yes, a certain amount of human oversight is needed, and a more general population understanding of what machine learning and artificial intelligence and deep learning is the only way for us to kind of prevent these systems from being a black box and from spreading bias throughout the world, and potentially affecting other parts of society. And in the chat thread, I looked up a couple articles in reference to this human in the loop concept, since it's something that I wasn't familiar with. And I'm posting them here for you guys as a reference, and I'll include them in the slides as well if you guys would like that. But feel free to click on those and peruse, which might give us all better understanding. Does anyone else want to add to that? Human in the loop or bias systems?
I think now we can move to next step.
Yeah, okay, not a problem. Yeah, let's do that. Okay, so this next part just talked about historical trends in deep learning. There's been this idea that deep learning has gone through specific winters, and what people mean by that is just the popularity of artificial intelligence has had peaks in different parts of human history. When the concepts were first derived, obviously, it was in like the 1940s and 1950s. And one of my favorite quotes from, I think his name is John McCarthy, who's considered like a grandfather of artificial intelligence, was that once it works, it's not considered artificial intelligence anymore. And I don't know if you guys have heard that saying before either, but that idea kind of resonates with me. That once we're developing a certain kind of technology and no one really understands the way it works, then it kind of takes on this sense of AI, right? Because no one really gets it. But then once it becomes really popular and kind of infiltrates the world, and most people are very accustomed to it, then it kind of loses that luster or that kind of mystique, right? And so it's no longer considered artificial intelligence. And artificial intelligence has gone by different names, right? Cybernetics and connectionism and neural networks. These are some of the different names that have been associated with AI that have had like these huge increases in popularity over time. So I don't know if anyone wants to add any comments or questions on that topic.
Yes, it was like AI when it came like in the early 70s. It was supposed to replace humans,
Right.
and that it was failures. That's why it became expert systems. And then until now, it started picking up because of the new algorithms.
Yeah.
And actually, it was a different way to look at artificial intelligence, and that's what make it pick up.
Definitely, that's what made it popular again.
Yeah.
And I realized that the first time I hosted this, there are some images that were in the book that I didn't include in these slides, and we can look at those really quickly here, just to make sure that if people haven't had a chance to read this chapter, that we're not like leaving anything out for them. So this figure here talks about kind of why deep learning and AI has become popular again. And so specifically, one of the main reasons is just the availability of data sets, right, that have become available. And so, and the size of those data sets as well, obviously with kind of the interconnectedness of everything. And now you have these kind of smart home systems and our cell phones, which are constantly collecting data on us all the time. These data sets have gotten much larger, and they've had more availability with open sourcing as well by organizations and tech companies. So if we look at kind of what's been available, this iris data set, which is one of the most well-known for doing machine learning when you're first getting started, that was around quite some time ago, right? Before the 1950s. Information on criminals, so information that's been kind of made available through the government. Those systems have been around for quite some time because they've been collecting data on people for a really long time, right? Through the census, and through every time anyone's arrested. And then, of course, the newer ones, which have really led to advancements in AI and deep learning, have been, especially ImageNet has led to huge advancements through the ImageNet Challenge. Is everyone familiar with that competition that takes place every year?
No, I'm not.
Yeah, so let me pull it up really quickly. So the ImageNet Challenge is one of the largest competitions in deep learning for image recognition. And it's called Large Scale Visual Recognition Challenge. And so this is what's led to a lot of the advancements, not only in the availability of open source data, but also in the accuracy of these algorithms. Researchers will compete every year to have highest accurate or most accurate algorithm that they develop, but then also they'll compete to increase the number of neural networks that they use within each competition as well. And so when you see like huge headlines about like the largest number of neural networks ever through ImageNet, this is where it comes from, which is pretty cool. So if it's something you're interested in getting into, computer vision, definitely look into this competition. And so these competitions actually have been going on for some time. They have ones as well for natural language processing. Obviously, robotics competitions have been around for quite some time. And this is all way before Kaggle was created. So Kaggle's kind of like a new iteration or new version of these challenges. So yeah, if you're looking for data sets as well, there's often links to the data that was used for each of these challenges. And from doing these challenges, they've been able to create larger data sets for the general public to use. So if you're doing anything with computer vision, even using TensorFlow, oftentimes you can access the ImageNet database, which is awesome. Okay, and then let's look at if there's any others here, or if there's anyone that has a comment on any of these other data sets. CIFR is not one that I'm familiar with. Is anyone familiar with that one?
You know, I'm not familiar with the data set, but one thing I've noticed is kind of like you mentioned, data. There's more data sets available, and I think especially with the compute resources that cloud vendors give us, because if you have massive amounts of data, sometimes that's a little. You might not be able to crunch the data, and
Right.
I think now we're at a point where not only do we have all this data, but we have all these computing resources that we can crunch data, which I think leads to more advancements in this field.
Yeah, definitely. Yeah, and they do cover that a little bit in the book as well. The hardware, the availability of hardware, especially large GPUs, you know, becoming much more easily accessible through, you know, just the cost coming down, but then also through cloud computing, right? With AWS, now you can rent server time and even play around with their basic like T2 free instance. Although be careful not to leave it running because you'll end up getting charged. I've done that a couple times by accident. But you know, and Google Cloud has, you know, their servers they make available. I don't know if Facebook does. I've never looked into that. But it's really great now that you can rent server time, so anyone can do machine learning and deep learning. And most laptops that you buy even today, you know, a lot of them come with pretty high processing CPUs, and some of them even come with GPUs built in. So I think that has, like you said, kind of led to this advancement and this newest wave of AI and deep learning kind of taking over. And then they do talk about the MNIST data set and what this has done. And this is, again, one of the first machine learning problems that a lot of people try to recreate when they're getting into machine learning. If you haven't played with it, it's obviously available. And even when you first spin up TensorFlow, you know, they have a Jupyter notebook with the MNIST data set already there built in for you to play with. So it's a pretty standard tutorial at this point. Is anyone not familiar with MNIST?
Yeah, I've heard of it, but in reality, I haven't, because I'm going through the tutorials on Coursera, and I guess there we haven't yet, we have some data sources, but they provide the sources and we can use them. Haven't done that.
Great. Yeah. So, and basically what it is just handwritten digits, right? And it's processed through computer vision in the same way that a regular picture, like of a person or a cat or a dog, would be processed, right? They look for specific features within each, you know, number or letter of the alphabet that someone writes, and then through that, they've been able to recreate handwriting. So now you actually have computer-generated handwriting. And there's actually a few people that have published apps where you can just type something into a computer and have it printed out in different people's handwriting. Let me see if I can find a link to one computer.
Yeah, you're right. Actually, it reminds me of this. So basically, I also heard that somewhere in some paper that there is this whole field of generative adversarial network which are being used to fabricate or generate more data from existing data. Looks like this looks like something like that, right?
Yes, yeah. So that's part of what's happening. Once you train a neural network on a specific data set over time, you can actually get the computer to replicate, you know, those images or that type of data. So I just put another link into the chat thread, and this is from UCL News out of the UK, where they talk about text that has been generated from computing systems. So check it out if it's something you're not familiar with. And then here, they talk a little bit more about increasing model sizes. So that includes the hidden layers in the neural network, and that's part of what I brought up with ImageNet, which is a big part of their competition, right? How many hidden layers can you actually use, and does that actually give you higher accuracy or a better output? So they've been found at certain points just adding more hidden layers doesn't necessarily increase the accuracy or give you a better output depending on what the goal is that you're trying to achieve. And then let's see. Oh yeah, and then they compare this to the connections of neurons that we have, you know, as humans, or they also look at cats and mice and fruit flies, which I thought was really interesting. So no computing system, none of these machine learning algorithms or neural networks has been able to match the same connections per neuron that us as humans have, right? And some people say that we're not really going to get to general artificial intelligence or strong artificial intelligence. I don't know if everyone's heard of those terms before or understand the difference between narrow AI and general AI or strong AI. But the idea of strong AI, right, is an artificial intelligence system that really can think on its own and act on its own and learn on its own, and even have like its own like feelings. So obviously there's been, you know, that's when they say we'll actually get to strong AI when a computer can have as many neurons as we do. Yeah, and then they just showed here the increasing neural network size over time and what that's led to the achievements of each of these types of animals as a comparison. And this is something I wasn't aware of when I was first getting into AI and machine learning, was that a lot of the same ideas and concepts for neural networks and AI have been derived from biology and the way we have evolved as a species over time. So I appreciate this. My background's in biology and physical science. So I appreciated this when I first transitioned.
Yeah, the one thing that, sorry to interrupt.
Yeah, please.
Yeah, that kind of piques me is this notion that the human neuron is little, we don't understand the human neuron. So or at least I have a little difficulty in understanding how the neuron, by virtue of this activation that it does lead to a certain learning. Even though I kind of understand that high level that what it does, but why it works is something I still don't get it.
Why neurons work the way they do? Yeah, that can be a whole lecture in itself.
Okay.
Yeah, my general understanding obviously is whenever an idea or a concept is brought into your senses, right? So if you're looking at something or if you're hearing something, you have to interpret it just like the machine is interpreting it, right? And so signals get passed in through your neurons, you know, just the way that they are being passed through each hidden layer of the neural network here for artificial intelligence. And they have to go, in order for it to actually process through a neuron in your brain, it has to reach a threshold of activation energy, right? So here, I don't have a picture of a neuron in here, but I can pull it up. And so basically, if it passes a high enough threshold for activation energy, then it would actually be sent along to the next node, and that information will be carried over. So let me pull up this picture here. So in that way, it's really just the same, right? You're transferring information through math equations, right? And you get this membrane potential over time as the energy is transferred. So you start kind of here in each dendrite picks up the information from the other neurons that are around it, and then if it passes that activation threshold, then it gets sent through and then continues to be sent through each part, and it doesn't actually get interpreted until it reaches that axon hillock of the neuron, and then can be passed on to the next neuron. So that's just a really basic high-level understanding that I can explain at this point without digging into my old biology books. But if anyone else wants to add to that.
Yeah, I think that's fair enough. Yeah, I think the whole idea of this threshold of activation determining how the propagation happens.
Yes, exactly. Yeah. Okay, and then let's see. Do they go into anything else? So yeah, so basically, the scale and accuracy of these deep neural networks have increased. So this is, they actually do reference that competition specifically. And so the error rate goes up over time. So starting in 2010, the error rate, which was much harder for these, or is much higher for these specific deep learning models. And then over time, the error rate has decreased. And oftentimes because of those many hidden layers that people have added to their neural networks and they have experimented with over time. And they talk a little bit about reinforcement learning. And is everyone familiar with the concept of reinforcement learning?
I have general idea.
Yeah, do you want to share?
Yeah, I've heard about it, but I'm not too familiar.
Okay, so for reinforcement learning is something like, let's suppose you are playing, like how child learns, right? Like children's, they are playing each other and they are just seeing how the other person or next person is doing, and on the basis of that, children is going to pick those kind of qualities. Let's suppose in front of children, if you are saying something to somebody or some intense scenario or something, like if you are teaching this is flower, then from next time she is going to learn, like, or he's going to learn that that's the flower. Same way in reinforcement learning, what it does is it interacts, or it learns from the past experience. And there was one, I think one blog I gone through, it was about the chase, and first time it lost against its opponent, and next time it learned from that loss, and then it again came up with other ideas, and it learned from that mistake what it did before, and then it won that challenge. That was the one interesting blog was there. I am trying to pull that one. If I get that blog, I will send over to you guys.
Thank you.
Yeah.
Yeah, so the general idea is kind of the same as the psychological concept of reinforcement learning, right? And this is another way, another thing I think is really interesting is that artificial intelligence concepts also derive a lot from psychology. And so basically, as you're creating a system, especially in robotics, and you want the system to learn to do something, and you don't want to specifically tell it how to do it or guide it along the way, right? You set up an environment where this, let's say it's a robot, can kind of walk through a maze, for example, but then if it runs into a wall, right, you reinforce that the action that it took by running into the wall is, negative, and that it needs to avoid the wall. And anytime it does avoid the wall, then that's a positive reinforcement. And the same thing you do with a child, right? So if a child is, you're helping the child identify what a dog is, for example, and it sees a cat and it says dog, you as the parent have to say, no, that's a cat, right? And so you're reinforcing that concept in the child's mind of what a dog is versus a cat. So reinforcement learning with artificial intelligence does the same thing. You have this autonomous agent, and it has to learn the task by trial and error. And anytime it does something incorrectly, you have to basically explain to it that it was wrong. But it's harder. You can't obviously talk to it. So, and what's cool though is I've seen some examples of where people have kind of run these reinforcement learning systems concurrently at the same time, so that the system learns really, really quickly, and it actually allows you to achieve, much larger goals. And I think I shared a video. There's one guy on YouTube I really like who is using reinforcement learning for doing gaming. And I can share you a link to his videos as well. He really tries to break down, not deep into the mathematics, but just the general concepts about what's happening in each stage. And he actually goes through an example where he builds this autonomous agent, and he runs them through a maze. So, let me, I'll put a link to his channel as well in the chat thread for you guys.
Today I will.
Does anyone else want to add to that? No? Okay, cool. Okay, so yeah, I'm putting the link here right now. And so that's the basics of this chapter, chapter 1, and everything that they covered. I think we've talked about pretty in depth. There's definitely still some other things we didn't necessarily go into, like what is parallel distributed processing. If you're not familiar with that concept, it's just being able to do mathematics equations simultaneously, or parallelly, but then also potentially distributed over many nodes, right, or many servers, for example, which has led to the advancements of AI and deep learning today. So that's part of what's added to the rise of AI and deep learning. So if you haven't had an opportunity to read this chapter of the book, I would say it's still incredibly valuable to take the time and read through it, and definitely refer back to this video. And since we're switching up the way we're doing these sessions, I will upload this video as well to our YouTube channel for reference, and then send it out to everyone that signed up for today's lecture. Or not lecture, but discussion session. I don't want this to be a lecture. But since it's already 12:35, I have other things to do on the weekend. I hope you do too. But I really appreciate you joining us today. And I will build out these slides a little bit more. And then next time we can dig deep into chapter 2, which is going into linear algebra, which honestly you have to understand if you're going to really start reading research papers, that have to do with deep learning and artificial intelligence. And even if you really start getting your hands dirty with TensorFlow and you want to understand what's happening in the tutorials, you have to have a good understanding of linear algebra and what's happening with the vectors at each stage in an algorithm. So thank you everyone for joining us today. If there's any last comments or questions, we can open the floor for like 5 or 10 minutes. And then, of course, all the resources that have been shared in the group chat, I will share with you guys as well online. So let's open the floor. Does anyone want to add anything else?
No, quick question. So this the slides that you're having,
yes.
I missed the link. It's there on it's on GitHub.
Yes, yeah. So let me pull that up again. Thank you for bringing that up. So we have a GitHub repository. So it's through Excelii, which is my nonprofit organization. But here the repository is called the AI DL Enthusiast Meetup. And if you're on the main slide, and this is also linked in the Meetup discussion. So here, if you just click on Deep Learning Book Review, Weekly Study Sessions, that'll take you into that directory specifically, and then we break it up by chapter, which is what we've done in the past. If you just click on the chapter, so for chapter 1, either up here or down here, you get taken into the more detailed. Here we link to the chapters of the books, just for reference. We add the presentation slides, which are right here. Online, and here's the link to the original YouTube video that I did about a year ago. When we first started these sessions, I was way less knowledgeable at the time, but it was such a valuable experience, which is why I wanted to run through these again with people. So yeah, if you want to, you can either search AI DL enthusiasts meetup in GitHub, or it's, like I said, it's referenced on the meetup page. And then also the way these sessions are run, I would still like there to be a different lead for each session. I don't mind leading chapter 2, but for future sessions, it's helpful if more people kind of prepare material ahead of time. And also, I strongly believe that one of the best ways to learn is to teach others, because that has helped me so much in my process. So here on the meetup page, we have this presenter sign-up form. I just recently updated it for 2018. So if you click on the presenter sign-up form, there'll be several tabs at the bottom. Let me make this larger so you guys can see it. So the tabs, you'll see, so 2017 online and 2017 in person, we were hosting these both online and in person, but now for 2018, we're just gonna do online for now. All you need to do is, if you want to sign up for a specific chapter, put your name, your email, so that I can interface with you directly and get, make sure you're prepared for the session before hosting it. And these will just be in date, usually 1 week out. If you need a little bit more time than that, we can try to do that and accommodate that as well. And then as we went on and the subject matter became more dense for each chapter, we started breaking up the chapters in half, so people would have an opportunity to just really dive into a specific section. And then oftentimes, as if you can see from previous versions, we would share additional resources that were discussed within each chapter. So we'd like to continue doing that as well, and just using this as another way to learn and share resources and kind of create an open source repository of information for people that are kind of on their journey learning about AI. So please, I cannot encourage you more to sign up to be a presenter. So here you can see the chapter presentations and additional resources repository. Here's a link to it right there in the meetup. Just a reference to, this was posted on Reddit a while back as an idea, and obviously it's taken off. Yeah, are any other comments or questions on that from you guys?
I just had a question. It looks like last year you did do in-person meetups as well. Why the change? Was that because of space limitations, or?
Yeah, we did. We've used many different spaces in order to host sessions, and we have several different kinds of sessions, right? We have these deep learning book sessions. We have other research discussion sessions. We have ethical AI discussions. We've hosted workshops. So yeah, sometimes spaces become available to us and sometimes they don't. And then sometimes we also have volunteers that step up to host on specific nights, and then sometimes they get busy with other things and they can no longer host. So it really just depends on the situation. We had a regular host for an in-person session for the San Francisco meetup for this deep learning book. They were no longer available after a certain point, so that's why we stopped hosting those sessions. As far as I know, the space is still available if we wanted to start those back up. I personally cannot commit to every single week, both doing online and in person, so I would need a co-host. If anyone is open to being a co-host, please just message me directly. I am happy to get you set up and get you aligned with a space, and then start hosting these. And then also, if there's any other type of meetup that you would like to host to help you kind of in your learning, right? I've heard some people say they were going through Udacity's courses or Coursera's courses. If you want to host a session specifically to review those courses, I definitely think that learning in a group is incredibly valuable And I bet there's some other people in our meetup that would love to come and attend and learn the material alongside you. So yeah, if that's something you guys are interested in, please let me know and we can get that set up.
Okay.
Okay, great. Well, thank you guys so much for joining us. And yeah, we will see you next week for chapter 2.
Thank you, Laura.
Thank you so much, Laura. I really appreciate it. Thank you.
Yeah, no problem. Thank you guys. Have a good weekend.
Yep.
Bye.
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 Bye-bye.
Done? What؟ أقول شيء